So, dynamic page caching. Originally, I actually thought I'll be presenting it together with Roman, who is actually the brains and the hands behind majority of this new code, but he prefers to keep his anonymity, so I guess he's hiding somewhere in the audience, and he left the bright lights and grinning on stage for me. But as I present this, please remember that I did very little for this code. It was all done and delivered to you just because of this great team of developers who worked hard to make all the changes, and my only contribution was to be lucky enough to work with them. So let's get moving. And this button. So a year ago, we delivered Magnolia 5.3. There was very little happening to cache in that version. The major theme was personalization, and the only thing we did for cache was that we introduced this so-called uncacheable entry to resolve some congestion issue and the concurrent requests. And but what it also made painfully obvious was that we need to do something about the cache. And you had to wait for a year to get Magnolia 5.4 with the new cache, but I hope that wait was worth it. Actually, while putting the slides together for this presentation, I realized there is much more to deliver than just the dynamic page caching. So what this talk is really about is actually the state of cache in Magnolia 5.4, because there were lots of changes. And just to clarify which cache we are talking about, because there are quite few of them, there is the Jackrabbit item cache, which is somewhere very, very deep near bare bones of the system. There are registries for all the various types used by Magnolia, which are sort of caches as well. There is the FreeMarker template loader cache, which precompiles the templates and keeps them in memory for you to preheat it to serve faster. There is the HTTP response cache, which is actually the Magnolia cache, or what's referred to as Magnolia cache. There is also browser cache, which we are using quite often, and there is a number of custom caches, like you might have one for the REST requests if you are heavily relying on integration using actually REST and whatever custom caches that you introduce. So do we really need more caches? Well, I don't think so. I think every time you have any system which relies heavily on cache, it's because there is something wrong with the performance or design of that system. So hopefully you don't need to rely on cache too heavily, but if you do, here is what we did for you. So in the cache implementation itself, we completely restructured and improved the module. This is how it looks like now. I hope it doesn't look too complicated. The structure is pretty similar to what we have in DAM, workflow, or other modules, so you should be familiar with it already. One change which there is for you is that if you were using, or for the cache which you had before, you will be relocated to the cache legacy, which will actually bring the Ehcache implementation and cache core. You also see that it completely splits the UI of the cache from the implementation. So if you want to install cache without the UI, say on public, well, the cache module is ready for that. You can just do so. Another thing which we did in there is that we actually separated config per cache. You might remember this configuration screen. You could configure the cache already before. You could set how many items you want in memory, whether you want disk persistence, overflow to disk, etc. But that one configuration was used for all instances of the caches, which was not always the thing that you wanted. As of now, as of Magnolia 5.4, if you create configurations that are matching by name the actual caches, Magnolia will oblige and will actually reconfigure cache engine for that given instance of the cache to have different parameters than the others, so you can tweak them and optimize them to whatever you need. Another thing which we changed in the cache implementation, for those of you who use multi-site and who tried ever to configure a site-aware cache filter or the caching separate per site, you might remember how painful it was. You could do it, of course, but you had to have multiple cache filter instances in the filter chain. You had to configure bypasses so they don't intercept each other. You had to configure the cache policies and so on. So it was a difficult task, and it was time-consuming to make sure that everything is right and testing it and so on. Well, as of now, what you get is you just enable the site-aware cache filter, and then in the cache tools, You have the screen in which you just tell Magnolia which of the workspaces have the site-specific cache. You don't need to touch the configuration at all. Magnolia will do everything behind the scene. Should you decide to change it later, you just come back to this screen, you uncheck some of the boxes, you click configure, and you are done again. As easy as that. Another thing which changed is that, as I said, we separated all the things. We separated the core, the implementation, the UI. You might remember that already in the past we said that you can actually replace Ehcache as a cache engine, as a cache backend with something else, and you could, but you could never really get rid of Ehcache. It was stuck there because we had dependencies in the code, because we had imports, and we're using the Ehcache code all around. This is no longer the case, so now if you really want to get rid of it, you can. So this is the same structure which I was showing before. Speaking of Ehcache, that's yet another big change which happened. In Magnolia, well, ever since we introduced the new cache in Magnolia, somewhere back in 2008, we were using Ehcache version 1.5. And it was actually replaced, and sorry, that slide is wrong, it was replaced with version 2.10, which is the latest Ehcache version. And in those, 7 years of development of Ehcache, actually quite a lot happened there. They fixed over 350 issues, or around 350 issues. So it was definitively worth of it. Some of the more visible changes there is that you might remember, some of you ran into it, the Ehcache 1.5 had a lot of dependencies. Some of them we force excluded, some of them were not necessary at runtime, etc., but there was a lot of it. And some of them were becoming so old that they were actually interfering with the other libraries you wanted to use. Ehcache 2.9, on the other hand, well, there is pretty much nothing left. So that's a good thing, right? Another thing which happened with the new Ehcache, somewhere along 2.1.2.6, something like that, the Ehcache team claims they replaced or rewrote completely the core engine inside of the Ehcache, and they doubled the performance of the core. Well, the reality is, when we measured it, it is faster, true, not double the speed, but it is still faster, so, well, we take what we can, right? One thing there, don't expect that when you migrate to Magnolia 5.4, suddenly your cache will be 10% faster. Those numbers vary, and it depends on how many items you have in the cache. So the more full the cache is, the more noticeable that increase in performance is. So it doesn't degrade as fast. Here's some chart if the numbers were too difficult to read. Another thing which happened in the Ehcache is that there is no more disk persistence. And before you start throwing things at me for that news, let's try to look at it in more depth. So the disk persistence, when do you actually need disk persistence? The cache, I hope we all agree, is meant for the production use. As a developer, you don't want cache in a way it actually hinders you. You would switch it off if you could, right? You only want the cache in production, which is under the load, where you need to or when you need to take whatever resources you can to serve the request fast. And when you actually restart the production servers, this is where you need the persistence, right? So there are pretty much only two cases when you should be restarting your production server. One is on update, and well, if you didn't know that before, what we do on update, we force flush the cache anyway, because you have changed your Java code, you have changed your templates, you have changed configuration, we don't know what happened to the system, so the danger of cache becoming obsolete, becoming stale is too high, so we force flush the cache anyway. So in that case, the disk persistence didn't help you. Or you restart the server when it crashed for whatever reason, so it crashed and you want to start it up again, but well, the persistence happens when you're shutting down the server, the Ehcache will offload everything on the disk, or that's how the persistence worked there. And if the server crashed, there was no time to offload anything to the disk. So the cache is stale anyway, and you want to flush, you want to get rid of it anyway. So hopefully that should be enough arguments for not crying anymore for the Ehcache persistence loss. If this is still not enough for you, if I didn't convince you, the good news is that you can just replace Ehcache with big memory. So you can just take the ehcache.jar, drop it, replace it with ehcache-ee.jar, that's the big memory, and you have the disk persistence immediately. We can't distribute it because of the licensing reasons, but you as user of the system, you can just replace it. And if you want, you can also obtain the license for big memory from Terracotta, and you can enable some other features in there. So if you absolutely need disk persistence, this is the way how you can get it. If that still is not enough for you, I have another great news. And that's that we have the completely new backend implementation of the cache. So one of the benefits of separating Ehcache implementation in its own submodule and being able to get rid of it is, and testing all those APIs and so on, we took a step at Memcached and we added the Memcached implementation, which is another cache engine backend or cache backend, which is available out of the box for you. You can choose now. We still ship Ehcache, not the Memcached, because it's embedded, so it's easy to configure. But if you want Memcached, you can just exclude the Ehcache, you can add Memcached implementation, and you're done. Why Memcached, you might ask? There are actually many reasons and many great features of Memcached. One of those is that it runs on separate servers. So if you look at the configuration like this, you can have Memcached, you can have it running on separate server, or you can have it running on Magnolia server. It doesn't matter to Magnolia itself. But if you have it on separate server, what you gain is that when Magnolia restarts, the Memcached server is still running, so your cache is still running, it's still there. You don't lose it, and you can keep restarting those production servers as you need. Another great benefit that you get is that Memcached is actually clusterable. So not only it runs on separate servers, but you can also add another nodes or another instances of Memcached into the mix, and you can scale it up as you need. Doesn't have enough memory anymore, well, you can just keep adding those nodes and increasing the memory without interrupting the service ever. And it's still not all. What you can do, you can configure it to become eternal. So instead of having all on one server, you can actually mix multiple servers. In this case, I'm just cross-referencing the two different public instances. So and the Memcached will understand this. If you have multiple nodes in the cluster, it will distribute and replicate the items between the instances. So if one of those goes down, the other one will just pick up the slack and continue working. So you don't lose your items, even should one of those Memcached servers crash. And that's still not all. The best piece is that you can actually share the cache. That's something you could not do with the Ehcache, at least not with the implementation that was there. So with the Memcached, you can actually have one cluster of multiple nodes of Memcached, and you can have each of the public instances talking to that cluster and share the cache. Not only you save the memory, but you also gain the performance because you don't need to generate each of those items twice for the separate cache. So speaking of performance, the measurements we did on actually two public instances show that when serving the first request, you double the performance of Magnolia or the cache. Here are some numbers showing the same thing. You see there is some random fluctuation around 5%, the statistics, but the difference which the which the Memcached delivers is significantly above. Or again, if you like the charts, here is one. So that's yet another reason why for really high-performing installations you would want to use this. And this is still not all. Since we started with those new implementations, there is yet another. There is a product called Supercache. And we added the implementation for this as well as yet another alternative. Why, you might ask? Well, it has some interesting features. Apart from being the external system and being a persistent cache, it also allows you to serve the items from the cache at the load balancer level directly. So what happens when you have the installation, first request comes through the load balancer, it reaches the Magnolia, Magnolia will generate the cache item, it will store it in Supercache, and it will serve it back. The second request comes, the load balancer already knows how to generate the cache key, so it will generate a cache key, it will look in the cache, it will find the entry, and it will serve it directly. So the request never even reaches your Magnolia installations, making it possible to perform even more. Because it's tied to the load balancer, there is a catch. It's not available everywhere. It's available only for those certain load balancer and for certain configurations. So right now, if you want to use Supercache, that one is limited to on-demand or the sys11 hosting only, but it is available. And it's yet another implementation. And hopefully, maybe you can think of some other cache products, and you should be able to very easily implement other ones as well. It really, adding those extra implementations was a few days of work. It didn't really take that long once everything was ready for it. Another thing which we did, in the cache tools, there is a new browser app. Actually, the whole cache tools is rewritten. You see here there is a new UI, same functionality as before, but new UI. But you might also notice that on top there is this browser tab. And if I click on the tab, what I get, Magnolia will ask me for login into the public instances. Yes, that's right, into the public instances. So I'm on Author, but I'm logging into public instances to display the content of the cache from all public instances. Why? Well, we wanted to allow you to explore your cache, to see what's in there. So you can actually download the items from the cache. If you have multiple instances, you will be downloading the content from all of those instances. We want to allow you to better control what's in the cache. So you can select those items, and you can just delete them if you need to force flush them. And you get one single place. Oops, sorry. This thing is getting in my way. And you get one single place which allows you to actually control what's in the cache. So you see here that, oops, too fast. You will see that there is actually, whether the content exists only on one public or both or as many of them as you want, as you have, you will see there. You can also use it to check, for example, how your load balancer is working, whether the cache is distributed evenly between the instances or not, etc. So in summary, you get the auto-discovery. You don't need to configure anything for this. It will find out the public instances automatically from the subscribers. It's done using the REST, our own REST server and REST client. So there is the custom cache endpoint on the public instances, which is enabled for the author. It gives you the single point of control for controlling everything that is there to be controlled. And it's implementation agnostic. It will work same with the Ehcache, with Memcached, with Supercache, or with any other cache implementation you add, because we are just accessing the API of the cache. We are not going beyond into the implementation. So, short demo. OK, let's see. I had my fair share of the failed demos, so this one is pre-recorded. And you see that I will just start the cache tools. I get this screen. I go to the browser, log in with my super secret password. And once I'm in there, it will fetch the information from all my public instances, and it will show it to me. If I want, I can just select one item. I click download. I will get it downloaded in the file system. Since it contains multiple items, it will be delivered as a zip file. So if I unzip it, please ignore the rest of my download folder, you will see that I get 2 copies of the images. I can very easily compare whether the content on the 2 public instances is the same or whether it's different. If I want to download, say, a whole page, including the JavaScript and CSS and all the images and everything, I can just select those multiple files. I download it, I get another zip file, and as you will see, I will get the exact copy of the content from both public instances which I have. So for all the files, they are actually denoted with the, oops, too fast. They are denoted with the name of the instance, so you will know where they come from. So what I will do now is that I will actually activate a page to force flush the cache and to show you that the app really reacts on what's happening on public. So give me just a few seconds to go through the publication process. I didn't want to cut it off from the video. Maybe also to get some breathing space for me. And oops, hopefully I will not fall down. So I assign it to myself, approve and publish, and we should be ready to go back. Back to cache tools, please. Yes. That's what I wanted. And it will refresh in a second. Yes, and everything is gone. My cache is empty. So what I will do now, I go to public side. I will browse the content quickly to generate some cache entries. And I go back to the app. I will just switch between the tabs to refresh it again. And you will see that I have suddenly some cache entries, much fewer than before. It's also a confirmation for me. You see there is pretty much just the HTML and one stray image. But it also shows you that the browser caching is configured correctly. The browser didn't request, again, the CSS, it didn't request the JavaScript, it didn't request most of the images either. So everything is okay. In case I want to search something in that cache, I can also sort by different columns and so on. So yes, there are possible other improvements, but hopefully this is already cool enough, right? I like it anyway. So personalized pages, I mentioned we did personalization in 5.3, and the only thing we did then was the uncacheable entry. And if you didn't guess it, the personalized pages, the page variants were actually uncacheable entries. That's why we had to solve that one problem. And they are cached now too. So if you get Magnolia 5.4 and you have page variants, they will be cached. How? Well, that's actually very simple. What we did is we just added the hook, so the personalization, it will provide a variant info into the cache key. So we are able to generate different cache keys per page variants, and we are able to store those. And yes, so each variant actually gets its own cache entry. You might ask whether you can share the fragments, whether you can share the portions of the page which are not personalized. In theory, yes, you can do it. If I can get there. What you need to do for doing this is that you need to configure such a fragment as dynamic, and you need to use the custom cache key generator, which pretty much would just remove the variant info from the information that are available to the cache, or ignore it, just to make sure that the cache entry is actually the same for all the variants. But we don't do this by default, and if you ask why, well, there is a certain complexity in doing this. And that certain complexity in combining the items and, hello? Yeah, good. And that certain complexity actually impacts the performance. So if you want to achieve maximum performance long term, it's better to actually generate multiple cache entries. You don't really care about the little bit of extra memory you generate for that cache entry, but it actually performs better if you keep them completely separate. Unless you have some super intensive, expensive content that you want to generate there. Anyway, moving on, advanced cache and dynamic page caching, that's why you all came, right? So now you get it. But hey, wait, isn't the dynamic itself the very definition of uncacheable? Don't we exclude the pages from the cache because they are uncacheable? Yes, we do. So let's redefine what the dynamic is. And in our view here, the dynamic is, or dynamic page are actually pages which are combined from different fragments, snippets, components, pieces of content, whatever you want to call it, which have different time to live. And that's actually what we will be taking advantage of. And how we do it? Well, we just render the page. You might remember if you look at Magnolia page, I'm sorry, this is the previous version of the demo, but I didn't have time to update it. So if you have a page which has URL like this, you might know that each of the components you have on that page have its own special URL under which you can access it. And there were actually people who were taking advantage of it for years, really, since 4.5, as far as I know. And they were using tools like Varnish or other to enhance that the URI information with some ESI or EPUB tag or with the simply time to live information, and using Varnish then to combine those snippets together to render the whole page. We thought we could do that, but maybe we could do even better. And that's actually what we did. So we introduced SiteMesh into Magnolia. There is now SiteMesh module. You are free to use it as well for whatever other purposes you want. It actually gives great opportunities for dynamic enhancement of the content, so I suggest you look into it, at least. And we added the SiteMesh filter into the filter chain before the cache. The SiteMesh itself is configured to listen to HTML only. It could potentially, and we tested it, it could actually change or process also the CSS or JavaScript or plain text, whatever you want. But for performance reasons, because we are interested right now in HTML only, we limit it to HTML and we ignore everything else. And what we do, or the rule which we have configured there, is that we ask SiteMesh to look for the inject URI tags in the content and replace those tags with the personalized or with the other snippet, with the dynamic or separately rendered content. now wait, what tags? How those tags got in, right? So this is the tags which we are now inserting into the content. This one in particular says that there is area branding, which I want to introduce into the about page, and I'm telling SideMesh to skip processing of it, and because it doesn't have any dynamic snippets inside, and I'm actually telling it that it has the TTL 0 because I keep rebranding my company every second. So how does it work, or how do those tags get in? You might remember this image for change. This is the image of our rendering engine, which at various stages does various things. What we did now is that we introduced something called the rendering listeners. And those rendering listeners allow you to listen, to observe the rendering process of every component, every page, every area, everything, really. And you can react at the beginning. So there is a listener before render method, and there is listener after render method. And we call those methods, or we configure the listener which react in those methods and insert the tags when they are necessary. So yeah, how does it know when the tags are necessary? So here I have still the configuration of such a listener. So there is a SideMesh listener which will render, it will insert the tag. You see there is a parameter for the path. There is the time to live, which it will get from the configuration. We say it's enable, it doesn't skip the rendering. We set some other parameters, etc. No need to know the details. I don't know them either. So where is it configured, or how is it configured? How does that listener know when it needs to react? Very easily in your component configuration. So here I have the command. That's such a typical dynamic component on a page. What you do, you just add there a fragment definition as a subfolder, and there you just tell Magnolia that this is a dynamic component. You want to use SideMesh for rendering that component, and you want to set some time to live, in this case 0. Every time the page gets rendered, this component will be re-rendered in the page. So in summary, what's happening is that we have the rendering listener that will inject the tags. SideMesh filter will look for those tags in the rendered content, and it will replace them with either cached content or rendered entries, freshly rendered entry upon encountering it. And since the SideMesh lives in the chain before the cache, what's happening when SideMesh is actually requesting those fragments, it allows cache to react on it without actually even knowing whether it's a fragment or who is it for, and so on. So for cache, it's irrelevant. Again, if you replace the implementation of the cache, it doesn't care. All of them will work with this very nicely. So to keep on, the other thing which happens is that you can have a pages which contain multiple of those fragments, multiple components with different time to live. So if you have something which is cacheable for, I don't know, say every 20 minutes, you can have it next to the fragment which is not cacheable at all, or which is cacheable for everything, I don't know, 2 weeks or whatnot, 1 day because it's a weather forecast, whatever. You can do it. And what happens is that upon expiration of that content, when the time since that entry was generated is longer than time to live for that entry, we will just throw it away and we will force a re-rendering of that content. And as I said, the cache doesn't really care. It will just cache it or not cache it depending what the time to live is and depending what the request for it is. Now there is one thing to remember. The whole reason why we did this dynamic page caching is to actually improve the performance. And while on its own it improves the performance, there are actually many things which you can do to help it do its job well. One of those things is to know that when you're actually rendering some dynamic components, we will have to request those dynamic components separately. We will have to send another request to rendering engine to render that component on its own so we can cache it on its own. The more such a components you have, the more time we will need to render. The other thing there to remember is that at some point, if you have too many of those components, the rendering itself might be actually slower than if you just exclude this page from cache completely. The turn-off point is somewhere between 10 to 20 components. So if you have 20 dynamic components on a page, you're better off not caching that page. The dynamic page caching will not help you there, most likely. Another thing to remember is that while we support recursive fragments, so you can have the dynamic component which has area with another dynamic component in it, and you can use that configuration, it's perfectly valid, unless that lower component has significantly longer time to live or is very expensive to render. It doesn't make sense for you to configure it that way because you just force extra rendering loop, and you are better off just declaring the top component as dynamic and forget about the bottom one. It will be pulled in with the top one all the time anyway. So that's that. Yet another thing to remember is if you have group of dynamic components which are living in the same area, you can have that, again, perfectly valid configuration, but if you want to gain maximum performance, it's actually better for you to declare the whole area as dynamic instead of declaring each of those components. Even if there is one component that is not necessarily dynamic, you're still better off having one dynamic area with 5 components than just 4 components next to each other which are dynamic. It's all coming down to the number of times we will call a rendering engine to render. That's the heaviest piece. That's what we want to avoid, if possible. So now let's say you believe me that it really works, and I assure you it does. You can test it for yourself if you download the beta. There are some numbers about the performance, and while the table might look a little bit crazy, this is the way how you read it. So this 5th column is what you have by default, or what you had up until now. If you served uncached page and there was no side mesh, that's the 100% which we take for our measurement. If you just enable the side mesh on such a configuration, what you see is the time to first byte will increase because the side mesh will do some buffering at the beginning, so it will take longer before it starts serving the first byte, but then it will burst everything out pretty quickly, so the total rendering time doesn't change. Now the interesting part comes, so here we have a page which is cached, and it has one snippet which is not uncached or which has TTL 0. So what happens here is that before, in Magnolia 5.3 and before that, you would have to declare such a page as uncacheable because of the dynamic fragment. Now you can have it cached, and you go down to 64% of the rendering time of the original. So you get pretty much more than 1/3, anything between 1/3 and 1/2 of the time. Now, if that snippet itself was cacheable for even short amount of time, say 5-10 seconds, and somebody requested it within those 5-10 seconds when that snippet can be cached, you see the total performance is pretty much the same as the performance if you just cache the whole page. So that's how good it is, and that's actually the difference between invoking the rendering engine and not invoking the rendering engine for rendering the sub-element. So you will get the slides later, so you can read those numbers again and cross-check them yourself. Now, some questions. Yes, can the fragments be shared by multiple pages? Again, as I was saying, in case of the personalization, yes, they can be cached. It's perfectly valid. It's perfectly possible. But because of the performance reasons and because of the changes which you have to do to the cache key, we don't do it by default, but it's perfectly possible. If we see in the future that there is a high demand for that, if we find some use cases where it really makes sense, we will take a stab at it and we will provide it. But right now, it seems to be a corner case for which, well, we need to see and evaluate the use. So with that, we are back on Rhine, ready to take a swim. I thank you very much for coming and listening.